In the previous lessons, we have already talked about how to write the chemical equations. And then why we need to learn the chemical equation, it is because we want to know the amounts of substances involved in the chemical reaction. For example, in this reaction, to making water, H2O, we want to make water, and then how many H2 do we need? We need 2 H2, and then react with 1 O2, then we can get 2 H2O here. So to put in, we should put 2 H2 and then 1 O2 so that the reaction occur to becomes 2 H2O. However, it is very difficult for us to counting one by one for the molecules. For example, O2 molecules, when we count it 1, 2, 3, 4, 5, 6, and then hydrogen 1, 2, 3, 4, 5, 6, it is a very difficult task. Just because for 80 mole of H2O, then we have already got around 10 to the 23 powers molecules there. So that means it is not 1, 2, 3, 4, but 10 to the power 23, more than a billion of molecules there. So it is very difficult for us to counting one by one. As a result, what we should do, we will counting the numbers by weighing the molecules or the stuff. Take an example. If we got one oxygen molecule, it is 13.01 gram, and then we have 10 oxygen molecules models, then it should around 10 times. So actually, if we have for example 15 oxygen molecules, then it will equals to 13 times 15, then we will got a number of gram there. It is 195 gram. So actually, for the scientists, when they want to measure about the mass, they will use this method to measure about how many grams reacting with each other. For the mass, you may remember that there should be some relative atomic mass learned before. But what does that mean for 16.0 and 1.0? If you remember, we have calculated the relative molecular mass as well. For relative molecular mass of O2, as we have 2 oxygen, so we say that it is 16.0 times 2, then it will be 32.0. But what is the meaning for the 32.0 then? What is the meaning for relative molecular mass? As we learned about these, the reacting masses, it is highly related to the relative molecular masses or relative atomic masses that we have learned. So we will further discuss about this in this chapter. Now the meaning of the relative molecular masses of O2, 16.0 times 2, O2 has 2 oxygen, so 16.0 times 2, then we got 32.0. While for hydrogen, you will find that 1.0 is the relative atomic masses, while 2, so we need to times 2, then we got 2.0. So the relative molecular masses tell us what? If we got 32.0 gram of oxygen O2, then we will get 1 mole of O2. Now you may puzzle, what is the meaning of mole? I will tell you later on. While another one, if we got 2.0 gram of hydrogen H2, then we got 1 mole of hydrogen H2. So the mole meaning we will discuss later on, which appears on page 71 as well. But when you see actually different elements, they have different relative molecular mass just because they have different masses of protons and neutrons. So the mass, the relative molecular mass will be different. And what is the meaning of mole then? If we further take a look, so 1 mole of that substance contains how many particles? It will be equal to 6.02 times 10 to the 23 particles. That is 602, or a lot of zero there. The number of that should be 23 particles there. So 6, after that 23 units there. So that is quite great or huge amount. But in our daily life, we also use these kind of counting method. For example, we will use dozen, pairs, or rims. For example, we use a pairs of sock and then a dozen of eggs, so that means 12 there, and a rim of paper, that means 500 papers there. So this kind of units means special numbers there, and then just similar to the moles. So if we say we have 1 mole, we should contain 6.02 times 10 to the 23 particles there. So for 1 mole of sulfur atoms, we got 6.02 times 10 to the 23 sulfur atoms inside. If we got 1 mole of sodium ions, that means we have 6.02 times 10 to the 23 numbers of ions. So on and so forth. So here are some examples. If we got 0.9 mole of sulfur atom, so how many particles present? Then we just need to do is 0.900 times 6.02 times 10 to the 23. Then it will be the answer of that. It will equals to 5.42 times 10 to the 23 atoms inside. So how about reverse? If we have 3.91 times 10 to the 24 atoms, ions inside this there, how many moles will be? So we just need to divide it by 6.02 times 10 to the 23. So this will equals to the number of mole. Then use our calculator to plus it. It will be 6.50. Now the unit of that will be mole. So to convert, actually if you want to convert the mole to the number of particles, you need to times the 6.02 times 10 to the 23. While if you want to convert the number of particles to mole, then we need to divide it by 6.02 times 10 to the 23. And this kind of 6.02 times 10 to the 23, we have a name called it, which is called Avogadro's constant. Avogadro is the one who find the number of particles for 1 mole, or define the number of particles for 1 mole. So we say that this is Avogadro's constant. For question 2, it is about how many molecules are there in 1.5 moles of carbon dioxide molecule. So once again, you need to convert is 1.50 to number of molecules, so you need to times 6.02 times 10 to the 23 Avogadro constant. Then the number of particles will be equals to 9.03 times 10 to the 23 molecules. While if you need to calculate how many atoms there, you need to know the formula for carbon dioxide. For carbon dioxide, it is CO2 inside. That means every molecule should contain 1 carbon and then 2 oxygen sticking together. So when we are talking about how many atoms inside, for 1 CO2 you should get 3 atoms. As a result, if we got 9.03 times 10 to power 23, so number of atoms will be equals to 9.03 times 10 to the 23 and then times 3. Just because every carbon dioxide molecule you got 3 atoms inside, so altogether there should be 2.71 times 10 to the 24 atoms inside.